again, everyone, and welcome to class number 3 in my bash scripting series. And in this particular class, what we're going to do is take a look at variables. What variables allow us to do is save information for later use. And the best way for you to see exactly what I'm talking about is just to dive in and get started. So let's go ahead and just do exactly that. In this lesson, lesson number 3, we're going to continue our bash scripting journey and add variables to our toolkit. In the previous lesson, we created a few scripts that executed simple commands, but when we add variables to the mix, we can start to differentiate our scripts. Let's begin. So here in my terminal, what I'm going to do is declare a variable right now. I'm going to call it my name, and I'm going to set it equal to J, just like that. And when it comes to bash, declaring a variable is literally that easy. You type whatever you want to name your variable, and then you include the equal sign with no space, and then in quotes, you could put some text like this, or even a number. You don't have to actually include text. So I'll press enter. So what I've just done is I've created a variable named my name, and I set it equal to J. I did this right on the command line and not in our script file. And I did that to underscore the fact that there's really not much difference between entering commands on the command line and adding commands to a script. A script will contain commands that the underlying command line interpreter understands, and commands on the command line can be used inside a script or as a standalone command interchangeably. So I declared a variable, but how do I reference it? One way we could reference a variable is to print the contents of it, and we could do that with the echo command. In the previous lesson, I used the echo command inside a script to print hello world to the screen. Here, hello world is a string. I have it in double quotes. So I simply instructed echo to echo what I have in the quotes here, but what I can also do is use echo to print the contents of a variable as well. Now recall, I named my variable my name. So what I could do is echo my name just like that, but this isn't going to work. Don't press enter just yet. Whenever we reference a variable in bash, we have to include a $sign in front of the name of the variable, otherwise it's not going to work exactly like you might expect. So without the $sign, let's just see what happens. It literally echoed my name. Now here, I didn't use double quotes, but it still echoed a string to the shell. The double quotes aren't required, they're just a good idea, especially when you have special characters that you're going to echo. But this isn't really what I wanted. I called the variable my name, but when I echo it, it just prints my name, not what the variable actually contains. But what I wanted it to do was print the contents of that variable. So in order to reference a variable, what we have to do is include a $sign in front of the name of the variable, just like that. Now when I press enter, the results are going to be completely different. It echoed my name. That's what I set the variable my name to be equal to, the name J. And now that I've included a $sign in front of the variable name, now bash understands that what J wants to do is actually print the contents of that variable. Instead of actually printing $sign my name, it's going to print the contents of that variable. So bash understands if it sees a $sign right in front of a name that you're talking about a variable, that's what you're doing. So it understands that, and it's going to treat whatever you type there as a variable. So if you haven't declared something yet, it's empty because I've never actually created a variable named new variable, so it doesn't exist. In this case, bash is treating it as an empty variable. But my name that was declared, I did set that equal to something, so it actually contains information. So you might be wondering then, why does bash actually require a $sign in front of a variable name in order to reference that variable? Well, don't follow along with this, but just consider this example that I'm about to show you. I'm going to create a variable named ls, and I'm going to set that equal to the text hello again. So I'll press enter, and if I type the ls command still works. Even though I declared a variable that's also named ls, it didn't interfere with the ls command. And that's one of the reasons why there's a distinction between typing something like ls or some other string, or typing a $sign followed by a string. A $sign and string is a variable. Bash knows you're referencing a variable. But the ls command, I didn't include a $sign in front of it, So bash understands the difference between the ls command and the ls variable because of that very reason. So if I ran echo and then $ls, it prints hello again, just like you see. So essentially, one of the reasons why we include a $sign in front of a variable name is that it actually helps us avoid name collisions. It's also mandatory. You don't really have a say in the matter. If you want to reference a variable, you have to use a $sign, so it is what it is. Now, there's one issue with variables that we want to keep in mind. If I was to type exit to exit out of my terminal, that's going to close the entire window. And then I'll open another terminal window, and here it is. So if I echo ls with the $sign, nothing happens. In fact, that variable doesn't equal anything at all either. So what happened here? It's important to understand that when you declare a variable in bash, it's tied to that session. Once you close the window, the session's gone. So any variables that you might have declared are wiped out. They don't survive a logout, login, or an exit of the shell. They're going to be within that session only. So the takeaway there is that variables, by default, they don't persist. Now let's return to our script, and what I'm going to do is include the variables inside the script, which is actually better because every time the script is run, then it's going to declare the variables every single time, so I won't need to do that manually. So here's the script from the previous lesson. I'm just going to wipe out everything here. And let's go ahead and create our next example. So the first variable that I'm going to create is the same one that I created at the beginning of this lesson, my name. I'm going to set that equal to j, and right underneath that, I'm going to type another variable. I'll type my age, and I will set that equal to 40. So what I'm going to show you right now is how to reference variables within your script, and this will help you make the connection between variables that you set and some of the possibilities that you can use within scripts. But even if you don't fully understand this concept, don't worry about it. It's going to get more clear as we go along. Anyway, what I'm going to do is type echo, hello, my name is, $, my name, period, and then an ending double quote there. And on the next line, another echo statement. I'm, and then my age, years old. So let's go ahead and run this. I'll save it first. Again, in the case of Nano, it's Control O and then Enter, and then Control X to exit out. Let's go ahead and run it. So as you can see here, it typed the sentence, hello, my name is Jay, I'm 40 years old. So now let's go ahead and explain what we've done so far. First, I set up two variables right here, my name and my age, and I gave them values. And what I want you to do now is pay special attention to the echo statements here. There's a few things that you'll definitely want to memorize. So right here, I have hello, my name is, but instead of actually typing my name, I'm referencing the variable my name. Now this is within the double quotes. So if you type double quotes, then bash understands that if you have a variable within the string, that it needs to print the contents of the variable and not the name of the variable. Now, if I was to include single quotes instead, and they have to match, I'll save the file and close out yet again. Let's run it. Now it's saying, hello, my name is, and it's actually printing the name of the variable. It's not printing what the variable references. It's actually printing the name of the variable. And with that example, you can immediately see the difference between single quotes and double quotes in an echo statement. And this is actually why I used double quotes in this example, because I wanted the contents of the variables to be printed. Now, if I was to use single quotes down here, that's not going to work very well. Why? Well, we already have a single quote right here in the string. So if I was to type a single quote at the beginning and change this over, then this isn't going to run. What bash is going to do is assume that this is what I want to echo right here because it's what I have in quotes, and the rest of it is not in quotes. I do have an ending quote, but bash is going to assume that this is the beginning of another quote. So what I have here is an uneven number of quotes. And this is a little complicated because I do, in fact, want the single quote to print, and thankfully with the double quotes and the variable name, it works out just fine. As an aside, single quotes would actually work if I went ahead and escaped out the single quote right here, which essentially tells Bash, don't count this as part of the greater single quote string, but that's not going to work well, so don't try that. We'll get into that later. I just wanted to let you guys know what the importance is of double quotes here. When we use double quotes in Bash, it's going to actually treat the variables inside these echo statements to show what the variables equal rather than the names themselves. Now, thankfully, if I close out of this, go ahead and save it, and then I'll exit out. I'll bring the terminal back. What I could do is execute the script again, and it still works. So the takeaway here is that by adding variables to the Bash script itself, we don't have to declare them every single time we're about to run the script. So that basically allows us to persist the variables. But okay, how do variables actually help us? I mean, we've just seen examples where we can print the contents of a variable, but why exactly would we want to use a variable in production, especially if we have a script that actually automates something instead of printing some silly text? Variables have many different use cases, and you'll actually see quite a few of the use cases throughout this series. But one of the major things that it helps us do is to avoid retyping. And to illustrate that, let's bring up our script again. And what I'm going to do is just delete everything here. If you were curious, in Nano, it's Control-K, that deletes an entire line. Just going to wipe out everything. Let's start over. So what I'm going to do is write 3 echo statements here. Now what I have here is another silly example, but don't worry, later on in this series we will definitely see some examples of some very useful scripts, but let's just go ahead and roll with this for now. What I have here are 3 echo statements, basically 3 things that I personally think are awesome. Now, I'm not going to run this script. I think by now you know exactly what's going to happen. It's just going to echo these 3 sentences right on the terminal. No surprise, that's exactly what's going to happen. But what does this have to do with variables? Well, if I wanted to change the word awesome to something else, then I'm going to have to manually edit the word awesome in each of the 3 lines. And, well, we don't like to do that when it comes to scripting. We don't like to repeat ourselves as much as we can absolutely help it. So what I'm going to do is create a variable named word, and I'm going to set that equal to awesome. Then for each occurrence of awesome right here, what I'll do is just change it to the variable. So as you can see, I've created a variable named word. I set it to awesome, and then I reference the variable in each of these 3 sentences. So let's save the file. Let's give it a run and see what happens. Well, I think you already know what's going to happen, but I'll run it anyway. As you can see, it just prints the sentences originally like I had them. But the cool thing about this is that if I wanted to go ahead and edit the word, what I could do is change the word to something like fun, for example. And again, I'll run the script. And I was able to change each occurrence of that word in one shot. Now, if this is a real script in a data center, for example, it could be doing something very important like backing up your server. And maybe you have a variable that's the directory it's backing up or something like that. In that case, you could just change what's being backed up by updating the variable. And that's a lot better than changing the path in every single occurrence manually. At least with this method, anytime you are actually referencing that variable, you could change what that variable equals in every single occurrence in one shot, and that'll save you time. So what I'll do is exit the script and give you another example of where variables might be useful. And specifically, another thing that we could do with variables is capture the output of a command. Consider this, for example. ls, as we've already seen, lists the storage. But what if I want to grab the output right here and store that in a variable? Well, what I could do is I could just copy everything here and put it in a variable, but that's not what I'm going to do. That's not very efficient. We definitely don't want to do that. What I could do instead is actually make a variable that's equal to the output of a command. And here's a quick example of that. I can create a variable named files. And just like before, I'm going to set it equal to something. But instead of typing something out, what I'm going to do instead is type $, and then in parentheses, I'm going to type ls, just like that. So I'll press enter, and the variable is now declared. Nothing printed on the screen, but we wouldn't expect there to be anything on the screen because, well, we wanted to create a variable, and that's what we've done. So if I echo the contents of that variable, as you can see, it includes the output of the ls command. How exactly did that work, though? Now, up until now, we've been creating variables with double quotes, manually typing inside the double quotes what we want the variable to equal. In this case, though, I don't have double quotes. Instead, I have a $sign and then a valid command in parentheses. So what we have right here is a subshell. And don't worry if this confuses you, we'll get into this more later on in the series. But a subshell allows you to execute a command in the background, and that's great because maybe you want to grab the output of that command and store it somewhere. So what this has done is send ls to the background, that's why we didn't see the output, and we created a variable named files that equals the output of the ls command. And not to be outdone, I could simply recreate the variable, and this time I'll use pwd. And if we echo the variable, then it now contains my current working directory, my present working directory, as the pwd command provides us. So that's yet another example of how variables might be useful. Now, to be fair, at this point, you may or may not be making a link to how this might be useful in practice. We'll get to that. But if nothing else, you now know how to declare variables. You can actually add a variable and set it equal to something like a string if you'd like. Or maybe you can make a variable that's equal to the output of another command because you want to use the output of that command later on. And yet another example that might be useful is the date command. And this is not specific to scripting at all, but by executing the date command on a Linux system, it'll give you, well, the date, just like you see here. If we were writing a script, which I'll pull up right now, let's see an example of using the date in a script. So I'll create a variable, and I'll call that variable now, and I'm going to set that equal to the output of the date command. So what this script will do is run the date command in the background and capture the output as a variable named now. And then I'll echo. The system time and date is, and underneath that, I will echo the contents of the variable that I named now. And just like you'd expect, it's going to print the system time and date is. That's just a string, nothing surprising there. And then it's going to print the actual date and time. Now, to be fair, instead of this right here, I could actually delete this and this, and then manually add the date command right here, and, well, the same thing is going to happen. The output is exactly the same, aside from the fact that the time and date is now a few seconds ahead, but you get the idea. So again, this wasn't a practical example, but what I did do is show you guys how to capture the output of a command, save it in a variable, and reference that right in your script. And well, this is something that we'll be doing again. So you're getting your first taste of it right now. It's a very simple concept, but something that you will use again and again into the future. Now let's see another example. I'll bring up the script, and let's write something that's actually a little bit larger than the last one. So again, we have the numeral sign, exclamation mark, /bin, /bash. Every single one of our scripts is going to have that as the first line going forward. Next, what I'm going to do is create a variable named name, and I'll type my name in there. I'm going to create a variable named now, and I'm going to set that equal to the output of the date command. So next, what I'm going to do is echo a simple sentence. Hello, and then name. Pretty straightforward so far. Then echo the system time and date is, echo now. And then on the final line of this example, what I'm going to do is type echo your username is $, and then user in all caps. But wait a minute, we didn't declare a variable named user. Well, don't worry about that quite yet. Let's save the script, and let's go ahead and run it. So check this out. It says hello, and then it shows my name. The system time and date is, it shows the system time and date. And then it says your username is Jay. But wait a minute, I didn't declare that variable, and it worked. So depending on how long you've been working with Linux, you either knew right away that was going to work, or you assumed I was going to get an error or, well, see a blank variable. But as you can see here, the script worked exactly like I intended it. So I think at this point, you should understand what everything does up until this last line right here. How did this actually work? Where did the user variable even come from? Well, within your environment, there are many default variables that are always declared. And $user in all caps is one of those. That variable is always going to contain the name of the user that you're currently logged in as. It was already there, I didn't need to declare it myself because, well, there's an environment inside your shell. The environment contains a bunch of variables that are already there, that are always there, and user is just one of those variables. And variables with a name that's all uppercase, like you see here, is commonly a system variable, an environment variable, something that's basically built in. Now, there's nothing stopping you from creating a variable and creating that variable with a name or variable name that's in all caps. You could definitely do that, and it's not going to error out. You won't have a problem. It'll work just fine. Assuming, of course, that you actually update the variable name everywhere that it is, but that's besides the point. Lowercase and uppercase variable names have an important distinction. And this is why you shouldn't create your own variables that have names that are all in uppercase. It's actually proper etiquette to use lowercase names for all of your variables, so that way, if somebody sees a variable being referenced that's in all caps, then that person will understand that you are referencing an environment variable that's in the underlying system, and it's not a variable that you created yourself. Again, there's nothing stopping you from creating your own variables and uppercasing everything. I just recommend that you don't do that. It's probably better just to go along with the best practice and name your variables with lowercase names, and that way everybody will know when you are referencing an uppercase variable, then you are referring to an environment variable. So I'll exit out of this. May as well save the changes. Anyway, if you're curious which variables, which environment variables you have within your session, you could find out by typing env, just like that. And as you can see here, I have a ton of variables that are already declared. I didn't declare any of these variables right here. The underlying system actually declared these for me. So if I scroll through the list here, I should be able to find the user variable. So we have username, we have home, and right here we have user. And that's where I got it from. As you can see, it was declared right here in the environment. We have a bunch more. So for example, I have term. I could echo the contents of that. We also had one for home. So if I exit out of here, you can see what that equals. Just like within the script, we have user, and there's a bunch more. But anyway, what I'm going to do is close this lesson right here. That was a lot of information. Basically, the takeaway is that variables are great because they enable us to save information to be used later. Variables also protect us from retyping the same thing over and over again, because anytime you are referencing the same thing repeatedly, it's almost, if not always, a great idea to use a variable instead. So that way, you only need to edit that one variable in that one line, and everywhere else that variable is being referenced will automatically work, and that just helps you avoid human error. So there you go. I hope you enjoyed this particular lesson. And if you did, please click that like button. I would really appreciate that. And the next video in this series is already uploaded, so feel free to check that out whenever you're ready to do so. Anyway, in the meantime, thank you so much for checking out this video. I really appreciate it, and I'll see you in the next video.